Hi, I'm Nick Houtman. I'm the editor of Terra magazine here at Oregon State University. You know, most of us will never get the chance to look directly into the heart of a molecule, but undergraduates today get to do that. Scientists 60 years ago were building machines to look into the spaces between atoms. Behind me is an electron diffraction apparatus built by Ken Hedberg, who is an emeritus chemistry professor here at Oregon State. Undergraduates in his lab get to use it every day in their search for what it is that makes molecular structure what it is, and to investigate the properties of atoms. So come along and listen to what Bob Johnson and Lou Costello have to say about their research in Ken's lab.
This is a gas phase electron diffraction apparatus, and it's basically a big vacuum chamber, and all this stuff over here pumps to keep it pumped down to really low pressure. And up there is an electron gun. It's basically a cathode ray, and it fires straight down through the chamber, and we use these ports here to inject gas into the chamber, which the beam goes through, and then we have a box down here that's got films in it, and when it interacts with the gas, it diffracts, and the electron beam does, and we record it on the films, and we develop them, and then we process the films, and we can extract information about the molecular structures of whatever gas we're injecting in its gas phase.
So the nozzle will heat up the sample to put it in the gas phase, so we can actually take pictures of it with the beam. It's squaric acid. It's a cyclobutene with just hydroxyl groups off of the side. So it's a pretty simple molecule.
It's related to a bunch of other molecules that have been studied in here, so we're trying to do sort of a group set of these cyclobutene derivatives. So this, I think, is the starting point for all of them. And a lot of them are made or just substituted squaric acids. So
this is the base molecule, and the rest of them are derivatives of this.
And what do you expect to learn?
And precise information about the structures, and hopefully some insight into ultimately the electronic structures of these kinds of molecules. So.
We're also interested in if there's one double bond in the the square of it, and we're kind of curious if it moves around the square or if it's stationary, to see how resonated it is.
Since Ken Hedberg built this device in the late 1950s, he and his students have analyzed the structures of hundreds of molecules. Perhaps the best well-known was a form of carbon called carbon-60, or the buckyball. Their work has been supported continuously by the National Science Foundation, and today all of his grant support goes to supporting undergraduates like Bob and Luke.